In this video, you will identify parts of a circle and determine what fraction of a circle is a particular angle measure. So beginning with different terms or parts of a circle, we have first off our circle. Alright, so our circle, by definition, is a closed curve in which every point is equidistant from a fixed point or a center within the curve. This word equidistant means equal distance. So you notice every point on the circle is the same distance from the center. Doesn't matter if I'm over here. Okay, this distance will be the same as it is over here at this point. The same distance from the center. So that is your definition of a circle. Now in writing the name of a circle, we name it by looking at the center point. So right here the center is O, so we can call this circle O. And our circle symbol is basically a circle, a small circle, with a point in the center. So that's how you write circle O. Now we've already mentioned the center is going to be point O. It's the point in the middle. And then we have what's called the radius. The radius is the line segment from the center to any point on the circle. So for example, the segment from O to R is a radius. It's going from the center to a point on the circle. And then OL would also be a radius because it is a segment going from the center O to the point L on the circle. So that would be another example of a radius. And by the way, the plural of radius would be radii. R-A-D-I-I. So radii is plural for radius. So OL and OR are two different radii of the circle. The next term we have is called a chord. A chord is also a line segment, but this is a line segment whose endpoints are both on the circle. So for example, segment SR would be a chord because both endpoints, both S and R, are on the circle. Also, notice RL would also be a chord. So from R to L, that's a chord as well because both endpoints, again, are on the circle. So segment SR and segment RL both are chords of the circle. Next we have what's called the diameter. The diameter, by definition, is a chord that goes through the center of the circle. So for example, segment RL would be a diameter because it's a chord that goes through the center. Alright, so basically the diameter would cut the circle in half. Now, as you're memorizing terms, sometimes it's helpful to have kind of dumb ways to remember things. So if you want kind of a weird way to remember the difference between a radius and a diameter. Okay, those two terms, many times people will get mixed up and confuse which one is which. So if you're struggling to remember which one is radius and which one is diameter, just think of the word diameter starting with the word die, so di. So if you want something to die, like a plant or something, to die, you would want to cut all the way through. So imagine this being like a tree or a plant. You cut all the way through the item to make it die. Right? If you want to kill that item, you want to cut all the way through. So diameter is the idea of all the way through, cutting all the way across. So kind of a dumb way to remember, but it might be helpful for some of you. But either way, just make sure that you remember your terms and know which one is which. We have another term on this slide, and the term here that we want to know is called a central angle. And this is an angle where the vertex is at the center, which makes sense. Central angle, angle at the center. So specifically, the vertex is at the center. So for example, here we have angle DOC. So right here, angle DOC. This would be a central angle because the vertex is here at the center. So that is one example. We also have angle AOC. So AOC over here would be another central angle because the vertex is at the center. So we have angles DOC and angle COA, both are central angles. So we've learned a few terms dealing with circles, and there's more terms that you'll learn later as you study math more in depth. Those are some of the basic terms. And now from here, we want to finish off by discussing a little more about the central angles. So in the next picture here, we see a circle, and the circle is broken up into different parts. Okay, so here at the top, we're starting at 0 degrees. So you see that right here, 0 degrees. So we're starting here at 0 degrees, and as you go around the circle, let's say we stop right here at this point. So we're stopping right here at this part on the circle. Okay, notice the central angle that was created. We've created a 90-degree angle. All right, so rotating around the circle from here at the top down to this point here, where it creates a 90-degree central angle, this is 90 degrees around the circle. All right, we keep going. So if we go all the way to here, notice that we've created a straight line from the top to the bottom. This straight line has 180 degrees. So if you rotate around the circle, starting at the top, and you go around here to the bottom, that is 180 degrees of a circle. And you can think of that as two right angles. 90 degrees plus 90 degrees gives you 180. And if you keep going, you go around to here, all the way to this point on the circle. Okay, notice we've created another 90-degree angle. So we add another 90 degrees to 180. That takes us to 270 degrees on the circle. So if you rotate around the circle, you spin around over to here, to this side, that is 270 degrees of rotation. And then if you keep going all the way back to where you started, that's another 90 degrees added, which gives you 360 degrees total. So we have 360 degrees in a circle. So if you start at the beginning, you go all the way back around, right to where you started, that is 360 degrees. All right, which you see this all the time, even if you're into like sports, like skateboarding, for example. If you do a 360, that means you're spinning all the way around a complete circle, a complete rotation. If you do a 720, that means you're spinning around twice. 360 plus another 360, that gives you 720. All right, so if you do a 720, that means you've spun around in a circle 2 complete times. All right, so make sure you know that concept, that the central angle kind of tells you how far you have gone around the circle. And these angle measures also we can convert into a fraction. So here looking at the 90 degrees. So if you start here at the top at 0, you go down to here to 90 degrees. The next question we want to figure out is how far or what fraction of the way is that around the complete circle. Well, knowing that there's 360 degrees total in a circle to go all the way around, and we traveled 90 degrees of that, we can write that as a fraction. We can write that as the angle measure, 90, divided by the total measure in a circle, which is 360. So we take 90, divide by 360, and then we reduce that, divide top and bottom by 10. So now we have 9 over 36. And then we can divide top and bottom by 9 to get 1 over 4. So 90 degrees is 1/4 of the way around the entire circle. And I think we see that because there's 4 different parts. Each 90 degrees is another 1/4 of the way around the circle, because there's 4 equal parts. All right, continuing around to 180, to find the fraction of the circle that this is, we take the 180 and then divide by the total of 360. So we take 180 divided by 360, and we can reduce that to give you 1 over 2. So going all the way to 180 degrees in the circle, that is 1/2 the way around the entire circle. And we could do this again for 270 degrees. We just take the angle measure of 270, then divide by 360. So 270 divided by 360, we can reduce, divide top and bottom by 10. That gives you 27 over 36. And then we can divide top and bottom by 9 to get 3 on the top and 4 on the bottom. So 270 degrees is 3/4 of the way around the entire circle. And then to finish off with 360 degrees, we take the angle measure of 360, divide by the total degrees in a circle, that's 360 as well. So we have 360 divided by 360, which equals 1. So we can say that 360 degrees is 1 rotation around the circle. So the process we've illustrated is that to find the fraction of a circle that a particular angle measure is, we take the degree that we're given and divide by 360. So here are a couple more examples that you can practice. So take a look at these 3 examples and see if you can get to the answer on your own. So if needed, you can pause the video and then unpause it once you want to check your work. So example 1 says, define the fraction of the circle that 40 degrees is. So remember, to do this, we take 40 degrees and then divide by 360, because 360 is the total amount of degrees in a circle. So we take 40 divided by 360, and we can simplify by dividing top and bottom by 10. That gives us now 4 over 36, which you can reduce by dividing top and bottom by 4. That gives you 1 over 9. So our solution is this 40 degrees is 1/9 of the way around the circle. Here's another example, example 2. We're given 120 degrees. So 120, this one we take the 120, divide by 360, divide top and bottom by 10, we get 12 over 36, and then we can divide both 12 and 36 by 12 to get 1 over 3. So 120 degrees is 1/3 of the way around the circle. One more example, example 3, we have 200 degrees. So again, we take the 200 degrees, put it over 360, and then simplify. Divide top and bottom by 10, we have 20 over 36, and then from here we can divide top and bottom by 4. 20 divided by 4 is 5, 36 divided by 4 is 9. So 200 degrees is 5/9 of the way around a circle. So in this lesson, we learned the different parts of a circle, and we also learned how to convert a degree into a particular fraction of the circle. And that concludes our lesson for today. We will see you next time.